Today we're working on 5B, and we're going to do all the problems. The first problem wants to know what is to the right of 1.25. So I look on my z-score table. There isn't a 1.25. There's a 1.24 and a 1.26. So I kind of need to take the average between 78.5 and 79.2. It's basically 79%. So the central area is 79, and 100 minus 79 is 21. What does that 21 tell me? That's how much the outsides have. And I want to know this outside, so I cut that in half and I get 10.5. Is that better? The evidence of my mistake does no longer exist, so you have no proof. Okay. Oh! All right, to the left of negative 0.4, always, always, always draw the picture. Negative 0.4 is here. So this is z equals negative 0.4. I don't have a table that shows me left area. So instead, I need to use the table I do have to calculate central area. And there's no negative 0.4 on the table. I just use 0.4. So z equals 0.4 gives me 31%. So the center is 31%, which means that the edges are 100% minus 31%, which is going to be 69%. And half of that area resides in each tail, so we cut that in half, and we get 34.5%. So this area here is 34.5%. And if you're off by a little bit, that's fine. No big deal. Okay. C, to the left of 0.8. Where is 0.8? It's going to be right there, and I want to calculate that area. So the central area at 0.8 is 57.6. So how much would the tails include? That would be 52.4. So divide that by 2, and I get 26.2. And we want this area, which is 26.2, plus that area, which is 57.6. So when I add those together, I get 83.8. Did I do something wrong again? What did I do wrong? Did I look up the wrong number? 0.8 is 57.6. Oh, 42. Yeah. There we go. 42, which ends up being 11.2. Okay, there we go. So that's 68.8. Thanks, guys. 70. Oh, man. Must be Friday. The bad thing is I can make these mistakes up on the board and there's no repercussion. But if you make a mistake on a test, there are serious repercussions. And you're going to wonder, how on earth did this guy graduate from college 3 times? Yes, I got an associate's and then a bachelor's and then a master's. So, all right. Number 1, D. Okay, this one's a little bit tricky. How much is there between 0.4 and 1.3? So how much area resides in here? Well, let's look up 0.4. When z equals 0.4, the area is equal to 31.1. And when z equals 1.3, the area is equal to 80.6. So this area here is 31.1, and this area here, probably out to there, is 80.6. So how am I going to calculate this blue area? It's half of the red and then half of the other blue and then subtract them. So 80.6 divided by 2. And then we're going to subtract 31.1 divided by 2. And we get 24.75. Uh-oh. Did you get something close? If you're a little bit off, if you rounded somewhere, it's not a big deal. Yeah. Isn't it great when you look up the weather and it says there's an 84% chance of rain today? Is that different than 83% chance of rain? Like, how do you... Yeah, so as far as rain calculations go, I think they should do like 10% increments or maybe even 20% increments, because when I see a 6% chance of rain, like, what does that really mean? Like 6%? Really? Yeah. Sometimes we pretend to be more accurate than we actually are. So if you rounded these to whole numbers, you're going to be close enough. The only place it's really going to matter are on the edges. Near the edges, rounding will have a more drastic effect. So, all right. Between negative 0.3 and 0.9. So here is negative 0.3 and here is 0.9. So I'm going to take half of the 0.3 area, this, and half of the 0.9 area, that, and then add them together. So the area for 0.3 is 23.6. Cut that in half. The area for 0.9 is 63.2. Cut that in half. And what does that give me? 23.6 divided by 2 plus 63.2 divided by 2. I get 43.4. We getting the hang of this? Okay, outside negative 1.5 and 0.5. So this is a little bit of a weird question. Wants to know how much is here. How do I figure that out? So find the 1.5 answer, which is 86.6. And just take 100 minus 86.6, and we get 13.4. Okay. Fill in the blank. The area between plus or minus what equals 68%? 1 SD. Okay. What about 75%? How are we going to figure that out? Go to the table and find the area that says 75%, which is it's somewhere between 1.14 and 1.16, so we'll call it 1.15. Okay. 3. The normal curve is sketched below. Solve for z. So we have a normal curve and we have a central area of 90%. This is z, and this is negative z. Which z-score gives us a 90% area? So we look for 90%, which is in the third column, 1.64. So whenever z is 1.64, then the central area is 90. Okay, the next question is similar, but it wants to know what z-score creates an area to the left of 90. Is it going to be 1.64? No, what's the difference between these two? The left tail is included in the second graph. So did the z-score have to move to the left, or did it have to move to the right in the second one? Which one's bigger, the first z or the second z? The first one, because this graph already contains 90%. If I start grabbing more area, what has to happen to z in order to maintain 90%? It has to slide to the left and give up some of its area. Does that make sense? So there is more area to the left of 1.64 than there will be to whatever that number is. So how do we figure it out? And this is a trick that you're going to have to use a lot. I guess you could use calculus, but you don't need to. So what do we know about that second graph, other than there's 90% to the left? Z is smaller than 1.64. Bailey, did you figure it out? What else do we know? Well, my table only deals with central area. I could build a table with left area and right area, but there's no point. The central area table is enough. So is there any way to create a central area there? I didn't draw my picture very well, but what? So how much is here? 10, which means how much is here? 10, which means the middle is 80. And that's a trick that you're going to have to use over and over and over and over. Good. Where did this 10 come from? Well, that is 90. So if the left area is 90, then the right area is 10. And if we make the right area 10 and the left area 10, then the middle area is 80. Now what? Look up 80 on the table. So 80% is going to be 1.28. Does that seem reasonable? Yes, because it's smaller than 1.64. Okay? So if you are given left area or right area, then the procedure is find the leftover section. How big is that? Put the same amount on the other side to create a central area, and now you can use the table. And again, this is a trick that we're going to be using over and over and over and over and over. Okay? All right. Okay, number 4. A certain curve, not the normal curve, is sketched below. The total area is 100%. The area between 0 and 1 is 39%. How much area is to the right of 1? Would be 100 minus 39, which is 69%. If possible, find the area between 0 and 0.5. I can't do it. Why can I not do it? It's not the normal curve. It's not symmetric. Okay, I could give a guess, but not really an accurate one. 5. A certain curve that's not the normal curve is sketched below. It kind of looks like the normal curve. It is symmetric around 0, and the total area is 100%. the area between -1 and 1 is 58%. How much is to the right? Or sorry, how much is between 0 and 1? So I have a curve. It's not a normal curve, but it is symmetric. And I know that the area between -1 and 1 is 58%. So how much is here? Half of 58, which would be 29. Can we figure out how much is to the right of 1? 100 minus 58 tells me both tails, which is 42. Okay? Divide by 2, and I get 21. And then, if possible, find the area to the right of 2. Not possible. Why not? It's not the normal curve, right? I don't have a table. There is a table that exists, or I could build one using calculus, but I don't have that table. If I had the equation, I could use calculus to build a table, but I don't. So that's the beauty of the table. It takes out the need for calculus. We don't have to do calculus. We just have to look at tables. All right, that's it.